One of the most basic assumptions of fundamental physics is that the different properties of mass, weight, inertia, and gravitation always remain the same in relation to each other. Without this equivalence, Einstein's theory of relativity would be contradicted, and our current physics textbooks would have to be rewritten. Although all measurements to date confirm the equivalence principle, quantum theory postulates that there should be a violation. This inconsistency between Einstein's gravitational theory and modern quantum theory is the reason why ever more precise tests of the equivalence principle are particularly important. A team has now succeeded in proving with 100 times greater accuracy that passive gravitational mass and active gravitational mass are always equivalent, regardless of the particular composition of the respective masses. The research was conducted within the framework of the Cluster of Excellence Quantum Frontiers. Physical context. Inertial mass resists acceleration. For example, it causes you to be pushed backwards into your seat when the car starts. Passive gravitational mass reacts on gravity and results in our weight on Earth. Active gravitational mass refers to the force of gravitation exerted by an object, or more precisely, the size of its gravitational field. The equivalence of these properties is fundamental to general relativity. Therefore, both the equivalence of inertial and passive gravitational mass and the equivalence of passive and active gravitational mass are being tested with increasing precision. What was the study about? If we assume that passive and active gravitational mass are not equal, that their ratio depends on the material, then objects made of different materials with a different center of mass would accelerate themselves. Since the moon consists of an aluminum shell and an iron core, with centers of mass offset against each other, the moon should accelerate. This hypothetical change in speed could be measured with high precision via lunar laser ranging. This involves pointing lasers from Earth at reflectors on the moon placed there by the Apollo missions and the Soviet Luna program. Since then, round-trip travel times of laser beams are recorded. The research team analyzed lunar laser ranging data collected over a period of 50 years, from 1970 to 2022, and investigated such mass difference effects. Since no effect was found, this means that the passive and active gravitational masses are equal to approximately 14 decimal places. This estimate is 100 times more accurate than the best previous study, dating back to 1986. LU's Institute of Geodesy, one of only 4 centers worldwide analyzing laser distance measurements to the moon, has unique expertise in assessing the data, particularly for testing general relativity. In the current study, the Institute analyzed the lunar laser ranging measurements, including error analysis and interpretation of the results. Einstein's theory of special relativity. One of the key aspects of relativity, for example, is that observers are never guaranteed to agree on what now is. This stands in stark contrast to the physics of Newton and even everyday intuition. Because we synchronize our clocks around the world, it's easy to assume that this synchronicity extends throughout the universe. If you snap your fingers, then everyone throughout the universe should be able to agree on the instant that you snapped your fingers, right? But relativity makes this false. Different observers, depending on their speed, will disagree on what now is. And the fact that signals must travel no faster than the speed of light means that now only applies to observers close to one another. If you snap your fingers, therefore, an astronaut on Mars won't find out for about 3 minutes. Now means something different to Martians than it does to you. What is the relativity of simultaneity? But as wonky as the concept of now becomes in relativity, some things, like causality, are preserved. All observers traveling slower, or at the speed of light, will always agree on the sequence of events, even if they disagree about the duration of time between those events. So, even in relativity, causes always lead to effects. And the past always takes place before the present, which always takes place before the future. We won't always agree on how quick that rate of progression is, but we'll always agree on the order. This relativity of simultaneity allows physicists to expand upon a philosophical notion. Humans have an intuitive sense that the past already exists and is locked in place, inaccessible to us except through our memories, while we continually experience the present. Meanwhile, the future is also inaccessible and unknowable to us, until we get there and it becomes the present. But perhaps that experience of time is just that, an experience. Perhaps the future is just as locked in place as the past, and we simply can't access.